Aiden, he's got a point.
How dare you insult gallium? Or what if we
Last time I checked, gallium wasn't cute. Okay.
You don't like gallium? You don't think gallium's cute? You gotta hold it and then it could slowly melt in your hand? I think that's pretty cute.
No, I want something that, I don't want something that melts in my hands. I want something that melts my heart, okay? What? And that's not gallium.
Melts your heart? You want a radioactive element that destroys you?
Like uranium.
Yeah, we're back to uranium.
We're back.
Everything goes back to uranium.
Okay.
So, but what if the rock was uranium? What if we had classroom uranium rock?
How dangerous would that be to our health? Like, we won't like just have it.
I don't know. What if we kept it? We'd have
Yeah,
to
it
keep
depends
in a
where
lead
you-
box or
yeah.
something.
Yeah. But then like we open it once in a while to gauge which.
I don't know, then we'd have to
It's-
get
it's
one of
for-
those like exposure monitors to see, or we have Geiger counters, so we'd have to like do some experiments. See
What
how
if we
many.
get like buy one of those radioactive China dishes?
Yeah,
Oh, we
that's what I
have
was
some
saying.
of
We could
those.
just go and search for
In
them.
a lab.
Not our mascot.
Then you want the plateware to be our mascot?
You know what?
It's radioactive.
Fiestaware.
Be like,
No, I like that idea. I like that idea. Though.
and
I
then
mean,
we
I'm thinking, you know, it's like, you know,
Actually, there are some old dishes that are made from like old uranium
we touched
Yeah,
the corn,
there's
like,
also-
you know,
I don't think we have that,
sand,
but
you know, just a little good
yeah,
luck.
we don't have that one in lab, but we have Fiestaware. But yeah, you're right. There's also uranium glass.
It was not uranium, but
It's fake news.
Yeah.
I don't know how Mercury hasn't come up. Mercury's a cool element.
Oh yeah, Mercury should be our mascot.
like the planet.
No.
Ah yes, the elements, the planet Mercury.
Although Gustav Holst the planets is awesome, so the planets, you know, there's like the whole suite, classical music. Go look it up on your phones.
What am I looking at?
Gustav Holst the planets. He wrote a theme for all the planets. It's pretty cool.
I thought they all had to be like named after gods, and the moons had to be like Greek gods or something.
Yeah, so the music is pretty epic. That's why you gotta listen to it. You're missing out.
God damn, what's that reaction?
That's not what we talked about. We didn't talk about you going bald.
No.
What did the doc? You're like barber just messed up, and you're like, all right, that's it. You just gotta go now.
Why did you start with the dog?
I thought you were gonna get like a taper or like a mullet, something.
Well, I just didn't want to deal with the hair, so I got rid of it.
That's pretty much. I either have this or nothing. There's no in between.
Yeah.
You didn't get like a fade or a taper. It's just
No,
like
I
all
just-
one.
Didn't want to deal with it.
See, my dad would always cut my hair just one style, every single time. And then I got to the point where I'm just like, no, I'm making my own money. I'm getting a fade. So I have, you know, I've done that. Never went back.
Like she just leaves one little.
Like I got
strand.
this.
Trust.
This is my style.
I get. If it's bad, it's my fault at least.
We're talking
Not
about
someone else's.
No, I still.
What's your mascot for Ken?
do it. For fun. I just,
My
my dad.
One
He
They
cut
gave
my hair.
me uranium with the-
Oh, your dad.
Yeah, my dad. My dad.
Oh,
So I'm just like,
I
after,
see, I see.
after that, I'm like, okay, I'm just going to go into.
And that keeps them safe, right?
It doesn't have to be.
Uranium?
What if we get like the China like break them and then like place
Yeah,
them in
I
like
don't know how
an
to do that,
orbital of like an
because
atom or something? And like
I've been
we'll get like
places
some
where
like
I have not been able to
art
get
students,
like
I was like, if you're gonna do it, that's fine. You're gonna.
and my hair grew out.
I mean like it'll be like
I had one time where my hair grew
I
out
worked
for
with
a
radioactive
semester.
China,
I like it.
right? I'm sure I can convince someone to do it for us. They died,
It
they
was
died.
last time, so it was like one of the first things that I did. Like,
And there's no safety issue too.
Yeah.
Oh, you could get a haircut in Ohio. No barbers in Ohio.
So, yeah, we'll go over it in class, actually.
Okay, so is it, it's something to do with the volume, right?
Yeah, yeah, so we'll go over it.
I'm really hoping she doesn't need it. I don't want to use it. This is my only class that I have anything. Okay. Yeah.
Because it was either, it was math.
Are we still taking notes? I thought we're just doing.
Oh, we're gonna do practice problems. Yeah, I just have extra notes to kind of re-summarize things, because I think everyone's struggling on the same stuff, but we'll wait till the official start.
Not today.
No, he's not here.
Oh, that's right, that's right,
He
yeah.
needs a day off.
I think he's just tired of us. I think that's the case. He's just like, I need a day off from you guys.
I need a day off. I'm not gonna tell you from what though.
I'll make you assume it's work.
So you're the I know, I totally wish I could. Started going back. I know, but this is a nice part. Andrew always sits here and I'm like, why am I here?
You just assume that it's a lecture, you guys. Okay, then. Okay, then.
So good at it. I've been like since. But of course when I got home, like I'm not home anymore and like doing stuff. Yeah.
I don't know if I did. I think I started last year.
Yeah.
I almost
Felt
stopped.
my but I think that's why people.
Oh, no, this one. For some reason, my brain went, because the physics lab was the least one I did. I was all like, no, that one was really fast. And I'm like, oh wait, no, I don't know what was wrong. And my brain was not working, and it was really tedious.
I'm back into another go. For me, it's
Well, I
like,
did get better. I want to do some more.
still,
Very
I still have
There's someone that over you.
something like stuff.
Bless you.
I think by now I've done that.
Like, I have a little bit of slow start, so it's like,
Oh, I'm the
That's all the
physics like lectures and stuff. I'm gonna get
no,
everything.
I was
think about
so
it.
bad at that
But-
too.
And then the blackboard shows.
in that. Oh my.
And so I can like prepare and do anything.
Okay, it's competitive, but everybody else is running
You know,
around.
I'm like, yeah, all of them are
Then I'm, yay.
it's like, you need to test it.
Just sit.
Yeah. I don't have to do
I'll probably start like.
I felt the same way. I'm like, okay, I'm ready to just hammer out. Like, oh, just get a head start.
I've gotten past the false start.
Oh, you're fine.
At this point, so I'm feeling pretty good about this term so far, but on Tuesday during the week, I did not have much. I was such a My brain was already like gone. I don't know if it was on Tuesday was like not there.
Yeah, I was trying to put just my stuff like it was comfortable, and I was trying to use it like I can allow them. No.
Yeah, no,
All right, so quick announcement before we begin. So RCC is doing some research. So this is part of the institutional research. And Alira, if you want to jump in and add anything, if you know more, feel free.
They haven't reached out to ISG about this.
Okay.
Yeah, this is like timely, but it's nice to see this.
Yeah, and so I was sent an email to solicit you guys' opinions. I've heard this is also going to be working towards work on like helping to support caregivers or like students with kids. So I don't know if that applies to anyone in here, but if you know of anyone, definitely send this along. I'll probably put this up as an announcement on Blackboard so you guys can see this. But definitely join because, again, they're doing all these different focus groups. So I'm not quite sure what it's going to be about, but getting your voice heard is really important. And then, of course, if you can get a gift card, that's extra bonus. So I'll put that up for y'all. Any other announcements or anything? All right, so let's sum up. So I said we would do practice problems, so we're going to do that. And it seems like everyone's kind of struggling with the same thing, so we're going to kind of re-summarize our scenarios. And so, right, we looked at 2 scenarios, both in class and then also in lab. And so that first kind of scenario, and I have it up here, is just, right, our strong acid, strong base titration. So strong acid with strong base. And so then most people are kind of struggling with the calculations, and we'll kind of go through them together, kind of what the general steps are. But you have before the equivalence point, so of course I put our little graph here just to remind us. So before the equivalence point, right, you essentially have to do your stoichiometry, and let's just do some example. So strong acid plus strong base. Right, so we do our reaction. And of course, the key point is we make a neutral salt. So we can ignore, right, everything else that we have to do for the weak base titrations. So we make our salt, we make water. And so before the equivalence point, we essentially have to do our stoichiometry. So then that gives us, so find remaining hydronium moles, right, from the HCl, which is the same thing. And then you have to recalculate the molarity every time. Right, with the new volume. So that was kind of the key point. And that was kind of the difference from how we'd seen this problem previously, because we'd seen it just like a pure stoichiometry problem, just looking at the equivalence point and calculating, right, how many milliliters. But now we're kind of doing something different. So we're adding different milliliters at each point, and then we have to calculate our pH. So then we get our new molarity over new volume. And then, of course, we can plug that into our pH. And we'll do one of these calculations together. So we'll do a sample one probably right now. So then pH is our negative log, of hydronium molarity. Again, new molarity. So let's practice that. So would you guys like to do, because you have examples of this in both your homework, and I have both of them pulled up. And so we could look at the homework problem, which is the same idea as your titration, right, as the first titration you did. So we could do one of these. But if you want to do your titration, we can do that as well. Well, let's try B to start off with. And so kind of a quick walkthrough, and this could maybe help you on your lab a little bit, because the first one is, right, no volume of sodium hydroxide added. So you're just plugging in the molarity that was given. Oops, sorry, I circled the wrong molarity. The molarity given. So same thing, I'll flip to the lab. I'm trying not to confuse people by jumping around, but also trying to show. So same thing, so I should mention, I don't know why the 3 is there. I should fix that for the future. And so what's the pH if you plug it in? So you just plug in your molarity. So at our starting point, what did y'all get? So it should have been 2. So that was the first bit. And I'll just plug that in. So negative log of our starting molarity. So that was 2. And so now let's go back to our homework and try that problem together. So we'll skip the first one because we said, okay, that's just plugging in that molarity. And we can do this really quickly. So started at a pH of 1, but now let's do B together. So how do you do that? And that's, again, the same process you're doing for your lab.
You start by finding the moles of each, or in this case, millimoles is easier because we have it in milliliters, so just multiply the volume of each compound by its concentration.
Excellent. So let's walk through that together. So then we started with how many millimoles of acid? So 5 millimoles, and it's probably helpful to write out our reaction, just in case. So 5 millimoles of acid, and then how many moles of, or millimoles of sodium hydroxide?
1.
So 1, so 0.1 times 10, so 1 millimole. And so now we can do, right, change plus equilibrium. So the reaction essentially, so now react. All of that goes away. We're left with 4 millimoles of HCl. But then don't forget, so now what's our new volume? So new volume is 60 milliliters. And so now we have to find our hydronium concentration. So if you want to leave it in millimoles, you can do 4 millimoles over 60. So that works for your molarity. And then plug that in. So that's your pH. So 1.176. So do y'all want to try that for one of your lab volumes somewhere before the... And so, right, exact same process. What volume do you want me to plug in of NaOH added? What do you guys have on your sheet? So you want to do 1 milliliter? So let's do 1 milliliter. And so I'm going to work in moles just because I'm too stupid to work in millimoles. And so let's start off with our reaction. Again, HCl, sodium hydroxide, gives us water and our salt. And so how many moles did we start off with? So probably 0.1 millimoles, right? Or 1 times 10 to the negative 4th. So 0.1 millimoles. I'm just writing it both ways. And so then if we added 1 ml of sodium hydroxide, so now we have 1 times 10 to the negative 5th, or 0.01 millimoles. And so do our reaction. So I'm calling change plus equilibrium, or reaction. So I'll plug it in. So 1 times 10 to the negative 4th minus 1 times 10 to the negative 5th. So really small. So this goes away. And we're left with this for our acid concentration. And then new molarity. So what's our new volume? So we started with 10 plus 1. So volume is 11. So divided by 0.011. So new molarity, and then negative log of this. So I get about 2.087. Let me know if that sounds right to people. So I see thumbs up. Get that in. So 2.087. So that was for 1 ml. So does that make sense for these ones? Again, we can go back and do some more, but I want to hit all the examples because I want to look at the equivalence points for the weak acid strong base titration because we should emphasize that. And so let's kind of go back to these overall notes. Okay, so then that explains this scenario right before the equivalence point. We looked at 2 problems like that. And then, so this is for, again, only our strong base, strong acid. So now at the equivalence point, right, then we can just say that our hydronium equals hydroxide concentration and our pH is 7. So again, right, that's just strong base, strong acid. And then what happens when you get past the equivalence point? What do you kind of have to treat it as?
You have excess hydroxide and not excess hydronium, so you need to calculate the pOH and then find the pH from the pOH.
All right, so excellent. So past that, and again, we can rewrite our equation just so we can remind ourselves. So acid plus base will give us our salt plus water. But yes, so past our equivalence point, right, we're getting rid of all our acid. So then we're finding basically how many moles of sodium hydroxide we have left over. Of course, right, recalculate molarity based off of the new volume, and then get pOH, and then of course pH from that. So let's go back to our homework for a second, so we can do that problem together. So we'll skip these again. If we want to do these at the end, we can. And then, so glancing at this, so we use 0.1 molarity of HCl, 0.1 molarity of NaOH. That makes it easy. We started with 50. So this is our equivalence point. And we can know that this is 7 from that definition. And then let's calculate the 75 milliliters of sodium hydroxide added scenario together so we can practice. So take a minute or two and then we'll go over it. All right, let's start walking through it together. And so we can start with our same information as from here, right? So we started with 5, we'll go back to millimoles for now. So 5 millimoles of our hydrochloric acid. And now how many millimoles of sodium hydroxide do we have? or moles. What? Oh, 7.5, thanks. So 7.5 millimoles. So we have, so if we're doing the millimoles, so people were taking, so we take our milliliters, so 75 times the 0.1 there, so then that gives us the 7.5 millimoles. Or if the millimoles is confusing, right, convert that to liters, so I can punch that on the calculator. So converting milliliters to liters, and again, times our molarity. And so there it is in moles. You could move it over, right, 1, 2, 3. Now that's millimoles again. All right, so 7.5 millimoles. So now we see excess. So now we can do our change or reaction. And so now we're left with 2.5 millimoles. And so if we're in millimoles, we need to divide by our new volume in milliliters, or we could convert back, whatever makes more sense. But what's our new volume? Just remember how much? I have to scroll back up. So we had 50 plus 75. So 0.125 liters or 125 milliliters. So if we're in millimoles, we can do 2.5 divided by 125. And so then that's our value for POH, right? So negative log of this is our hydroxide concentration. So now 2.5, let me just write the work. So hydroxide concentration. So POH was this. So 14 minus. So about 12.301. And we have 4 sig figs, so we can report to 5 on our POH. Do we want to do this for our titration lab as well? Do we want to see this again? Okay, I see people. And so give me one of your lower values. So let me think for a second. So using the same volume, so 10 was near our equivalence point. Right, so did everybody get that 10 milliliters was their equivalence point for the, I know some people haven't been in lab, so it's kind of not. So 10 should be our equivalence point. And then what volume did you guys go towards after? Somebody give me a number. So 10.5. Oh, yeah, okay, I got you. So yeah, 10.5 milliliters of sodium hydroxide, right? So let's try the math then together. So I'll give you a minute or two to start on it. I'll write out our reaction. So we're still with our strong base, strong acid titration. And again, looking at 10.5 milliliters of sodium hydroxide added. So I'm just starting to punch in some values. So we still had 1 times 10 to the negative 4th moles of hydrochloric acid. And then I have 1.05 times 10 to the negative 4th moles of sodium hydroxide. And then we do our math. So that goes away. So now let's subtract. So minus 1 times 10 to the negative 4th moles. Then we're left with this many moles, so 5 times 10 to the negative 6 moles of sodium hydroxide, and then a total volume, so 10 plus 10.5, so 20.5. So let's calculate our new molarity. Oh no, sorry, that's wrong. 20. There we go. And make sure I didn't screw anything up. So then this is concentration of hydroxide, so negative log of that to get POH, 14 minus that to get pH. So I got 10.38. And just make sure you double check my math there. Do we follow? So this number? I feel like double check your numbers because we can see what happened. So 1, 2, 3. I was just worried about messing up the volume because this is the new molarity. Like, do other people get this number or?
I kept my millimoles and milliliters, and I still got the same answer, or at least off by 1 significant digit. So.
Yeah, that sounds pretty good. I think I saw other people got, so okay on this one, so 10 point, and we should go out, well, let's see, well, we have 3 sig figs, so 4, so 10.39 for pH. All right, questions about strong acid, strong base scenario? And so now let's see. Have you guys looked at the homework? Because the homework, let's actually look at some notes. All right, so let's look at this again and what we were saying. And so, right, kind of the other scenario. And so you'll notice, right, we never really talk about a weak acid, weak base titration, just because that's not normally done. And then, right, it goes up pretty slowly anyways. And then you have to worry about your equilibrium constants for both. So we don't really do that. So then kind of the other scenario is either you're going to be looking at a weak acid with a strong base, which we did in lab, and then it's on your homework. And then you should be able to do this in theory. I'll probably have to do an example later or something, but in theory, right, you could also do weak base with a strong acid. We just haven't seen it. And so kind of the key points then is we saw with the midpoint where the pH equals the pKa. And then again, just appreciate, well, with that pKa changing, right, that changes your midpoint. Same thing, showing the same thing with weak base. And then we could go over this again because we kind of rushed it at the end, but we could prove this better and kind of go through the math and show why this is the case. So remember, we said the pH at the midpoint of a weak acid with a strong base is equal to the pKa of the weak acid. We can show the math. But then this is the part that we need to do together, because this can be tricky. And so the pH at our equivalence point is not going to be 7 for our weak acid, strong base, or weak base, strong acid scenario. And that's why we'll go through it. So like I said, we'll do the homework problem. But the pH of the equivalence point of our weak acid should be greater than 7. And so let's kind of think about, well, why is that? And we'll see. So if we take our general rate HA, plus we do our neutralization, so of course we make water, but then we make A minus, so their conjugate base salt. And so of course, right, with this being a base, then this is going to go on and raise the pH ever so slightly. And so we'll do, again, the math with that, so we'll have to take into account the Kb of that conjugate base. And then so same thing, if we were doing the opposite, you would be able to figure this out and then find out that the weak base has a pKa less than 7 in the titration once you get to the equivalence point, again, because in that case you're making the HA. But let's go through the math, because that will help make more sense. So let's look at your homework now. So very similar to what you did in lab, is just instead of acetic acid, you're using HF. And so, right, we need our pKa. And so I'll just give you, so the pKa for HF is 3.20. And then for lab, so I'll just jump over so we're ready. So what did we say the pKa was for vinegar, like 4.76 in lab? So just making sure I remember that. So 4.76. So right, it'll be basically the same. It'll just be slightly different pKa. So the process, though, is the same. And let's do the equivalence point, because that one is kind of the trickiest, and then we can look at before and after. So we have our equivalence point, and so let's just look at what we're doing. So we're titrating with the same molarity, so that's easy to figure out. So if we're starting with 50 mils of our 0.1 molar HF, then we expect our equivalence point to be 50, right? Because that's just when we're defining our moles as equal. So they have canceled out. And so let's look at that. So let's just write our reaction together. So HF plus our sodium hydroxide gives us sodium fluoride. So again, here's our basic salt. So remember that, right? So that's our basic salt plus our base, or sorry, plus water. Got overexcited. And so now let's do our stoichiometry, but we said this was the equivalence point. And so we can be in millimoles, so 50 times 0.1 gives us 5 millimoles of HF. So same thing for sodium hydroxide, right? 5 millimoles. That's just 50 here, our equivalence point. All right, so that cancels out, so that's all happy. But then we can't forget that we have made 5 millimoles then of our base, of our conjugate base salt, right? And so now we have to take that into account. And so now we have, right, 5 millimoles of our conjugate base. Let's go ahead and write out what's going on, right? What happens with our conjugate base? So now this is just definition of our basic salt, right? In solution, reforms HF, also makes hydroxide. That's our definition of our base. And so now we have to get our KB, right, to do this. So this is a KB expression. And so we can get KB though. So what's our KB? So we have pKa. So we need our KB. We could get it. So what's our pKb? Let's start with that.
Isn't that the, PKW divided by
So
PKA?
the KB, I think you have it. So right, the Ka times KB is KW. But then if you're in the pKa's, remember it's pKa plus pKb equals 14. So then we can get pKb, so 14 minus our 3.2. So that's our pKb, which then, right, we can take 10 to the power of that. So 10 to the power of negative 10.8. So then we get our KB value of 1.58 times 10 to the negative 11 or so. And so, right, is this looking familiar now? So this should be just like our ice equilibrium tables at this point. So we have our 5 millimoles, right? Well, we need our concentration, sorry. So 5 millimoles divided by, what's our new volume though? 100? I thought somebody said it. So 100. So now this is our new molarity that we plug into this formula. So we still following so far? And then this is just like our regular ice table now, right? So now we have to figure out, well, how much of our hydroxide do we have based off of our Kv equilibrium expression, just like we've done before. So, right, minus x plus x plus x. And then, of course, right, equilibrium. So this is just like before. And now we can solve x squared over 0.05 minus x, and probably make an assumption to get rid of this since we're at the negative 11. So now I'm just doing the math, so times 0.05, square root of that. And so that's right, hydroxide concentration. So negative log of this is our POH. So 6.05. And then, of course, you can find your pH. So 7.95 or so. So x, sorry, I didn't write what x was. X was 8.89 roughly times 10 to the negative 7th. I can write that. And again, that was for hydroxide concentration. Then we got POH and pH. So that one is a little tricky. All right, which one do we want to do next? So I guess we should look at kind of before our equilibrium position. And so, of course, right, step one is you have to do the equilibrium anyways, just to figure out your initial pH. So would you rather do that with the homework, or do you want to look at the titration lab? The lab? So let's just do it right initially. What's our initial pH? So just assuming, right, no sodium hydroxide has been added. And so let's just set up our expression. So we have our HA, and then obviously some of it will make hydronium, plus our acetate. And so then we're given molarity, so that's fine. So we can use this to 0.085 molarity. And then of course, so initial, and then change, right, minus x plus x for our equilibrium expression. And then let me get our proper Ka value, so 10 to the power of negative 4.76. So this is my Ka value. So 1.738 times 10 to the negative fifth. And so right now we can just solve just like we've done before. Is equal to, so x squared over 0.085 minus x. Probably make our assumption since it's negative fifth. And so let's see. So now just solving the algebra. So then I get this for x, 0.00121. So yeah, 1.212 times 10 to the negative third, which is our hydronium concentration. Oops. So plug that in for pH. So initial pH I get of 2.92 for our vinegar. And then what point do we want to try? So then, right from after this initial point, so then it's a lot of Henderson-Hasselbalch. And so you'll have to be determining how much of your conjugate base you're making right from your neutralization. Is there a number you'll want to plug in for sodium hydroxide and vinegar so we can do one of them? 1 mil of sodium hydroxide. So let's do that. So 1 milliliter. And so we can just walk through it together. So again, same thing. So write your reaction. So our acid plus sodium hydroxide gives us our conjugate base salt. So NaA. Sorry, I'm trying to abbreviate. So that's sodium acetate plus water. And then we still had, so let's calculate. I'm just going to convert this to moles now, because that'll be easier for me. So 0.085 molarity times our volume, which I'm going to convert to liters, just because I don't think in millimoles that well. So this many moles, so let me write that down, 1.003 times 10 to the negative fourth. And then how much base did we add? And so 1 times 10 to the negative fifth moles of base. So do your reaction. So all our hydroxide goes away, but then we've made, right, 1 times 10 to the negative fifth moles of our conjugate base. And we have our acid, so let's subtract to figure out how much acid we had. So 9.03 times 10 to the negative fifth. And so now what can we do from here? So what do we do now? So we have, right, our HA, we have our A minus concentration. So what's, I know y'all were doing it. Yeah, Henderson-Hasselbalch, right? So now we can, now that we have, right, our HA and our A minus, so our base and our acid, we can plug it into Henderson-Hasselbalch. And so I had to remind myself what the pKa was. So 4.76 plus our log. And remember, the volume doesn't matter now. So we should be aware of it, be thinking about it. But remember, your volume's going to cancel because you're dividing by the same new volume. So it doesn't matter. So then we can just take our moles remaining. And again, base over acid. And so I get a pH of 3.80 for 1 ml of sodium hydroxide. Questions? Comments? Yeah, so then this would be true until the equilibrium point. So I would say, right, use our Henderson-Hasselbalch. So I'll just put, right, HH here. Then you get to equilibrium, which I would have to calculate what the equilibrium volume would be. So equilibrium being just where their moles match up. But again, right, the pH of the weak acid, strong base titration is not 7, so that's kind of the caveat. And then after the equilibrium, then you're back to calculating excess hydroxide for these, which we could still continue to do practice problems. I just know that we usually take a break and do our quiz thing, but if that is more valuable to do some more problems to help with the homework, we can do that as well.
Can we get homework, but just like on our own? Can we just do one more, but like on our own? Alright? Does that make sense?
So do you want to do one of the homework ones on your own then?
It doesn't matter.
So maybe try the 41 of sodium hydroxide. So this is back to our homework, or we could pick another random value for our acetic acid one. But So do y'all want to walk me through what you did for D? So how many moles of HF did you have, or millimoles?
So, I know we kind of just throughout the whole, I guess, thing with this, we start off with the same amount of millimoles, so I got 5 millimoles.
So 5 millimoles, excellent. And then, so how many millimoles of sodium hydroxide? So 4, excellent. And then then we do our change or reaction. So all our sodium hydroxide is consumed. We're left with 1 millimole of HF. And then of course, we make 4 millimoles though of our sodium fluoride. And then molarity doesn't matter, so new volume gets canceled out. And then we can plug into Henderson-Hasselbalch at this point. So then pKa, so 3.2 plus our log. Then our base is our sodium fluoride. And then over our acid, so I get a pH of 3.8 for this one. What you got? Excellent. So 3.8. Yeah.
So we can use the Henderson-Hasselbalch up until the equivalence point in this one, and then after that, we use the concentration of the hydroxide?
Yeah, because then we'll be back just like before, where, except this time, all our acids being consumed, so we're trying to figure out how much excess hydroxide, and then, volume will matter again after the equivalence point, so then you'll have to take,
Like the way we did in, like, kind of at the equivalence point, or?
yeah, or like for our other ones, because we just need to find our concentration of hydroxide again, so however many moles remaining after the reaction, over your volume. So that's where the volume comes back into play, the total volume. Yeah, which was just like the strong acid, strong base. Right, we saw the same thing where it's calculating the excess hydroxide, and then, again, depending on that new volume. Yeah, so the volume really doesn't matter with the Henderson-Hasselbalch, because you'll notice, the volumes always cancel. So you don't have to worry about it as much then, but then once you're calculating your absolute concentrations, then you have to worry about it again. All right, that's probably a good stopping point. And so we'll do how we normally do. I do have our quiz of our welcome assignment, but definitely take advantage of this class period to ask questions and do, more of the homework in the lab if you need. And we can do more sample problems on the boards too if we want to go through them. So we can keep doing this. But I know probably people want to take a break too, and I'll stop our official stream, but definitely ask for help.